Matched die forming for composites is a manufacturing technique, particularly compression molding, where a mixture of fibrous reinforcement and a thermoset resin is placed between two matching mold halves. Under high pressure and heat, the resin liquefies and flows to fill the mold cavity, consolidating the composite material into the desired complex shape before curing and hardening into a finished part. This process is effective for mass production of structural components with high accuracy and tight tolerances. Matched die molding can produce parts at high production rates, making it a cost-effective option for large volume production runs. The process is highly automated, reducing the need for manual labor and decreasing the chance of human error. One downside is that it requires expensive tooling, including molds, dies, and fixtures. The initial cost of the tooling can be high, making it difficult for small businesses to enter this market. All the details on matched die forming of composites is described in this lecture. Matched die molding is a versatile manufacturing process that can be used to produce high-quality, high-precision parts with tight tolerances. Its ability to produce complex shapes and intricate details makes it a popular choice for a wide range of applications across various industries. Matched die forming for composites is a manufacturing technique, particularly compression molding, where a mixture of fibrous reinforcement and a thermoset resin is placed between two matching mold halves. Under high pressure and heat, the resin liquefies and flows to fill the mold cavity, consolidating the composite material into the desired complex shape before curing and hardening into a finished part. This process is effective for mass production of structural components with high accuracy and tight tolerances. In short, matched die forming process involves placing the material in closed die, followed by heating to shape the product. The product is removed from the die after cooling. Reinforcing fibers, like glass fibers, are combined with a resin system, such as a foamable unsaturated polyester, which may include a blowing agent for expansion. Matched die forming is used in various industries to manufacture parts from advanced composite materials. Examples include lightweight glass fiber reinforced plastic, FRP, articles, which can exhibit excellent energy absorption properties due to the foaming process. Dies are metallic in nature, having high degree of surface finish. These dies should be capable of sustaining temperatures up to 200 degrees centigrade at maximum pressure of 10 megapascals. The whole system can be designed to have vacuum port to allow better consolidation of composites pre-preg during curing if resin used produces any volatile gases. The mixture is placed into the lower half of the matched die, which is designed with a specific mold cavity. After closing, the die may open slightly to allow the resin, containing a blowing agent, to cure and expand, which creates a lightweight product with enhanced energy absorption characteristics. Once the resin has cured and solidified, the two die halves are separated to eject the final composite part. The dies are heated, and the upper and lower halves are then closed and compressed under significant pressure. The heat and pressure cause the resin to liquefy, flow, and fully impregnate the fibrous reinforcement, taking on the precise shape of the mold cavity. The correct placement of pre-preg sheets, with respect to angle of placement of fiber or ply orientation while stacking the sheets in die, as suggested by designer, is of utmost importance. As the curing is completed in short time, so this technique can be categorized as energy efficient. This process offers several advantages over other molding methods, including high production rate, good surface finish on both sides, low waste generation, suitable for complex geometries, producing repeatable items with possibility of automated manufacturing. The matched die molding process is a manufacturing process used to produce large quantities of parts with consistent quality and dimensional accuracy. However, like any manufacturing process, there are some disadvantages associated with the matched die molding process. Few limitations of matched die forming are high tooling cost. It can produce relatively flat or shallow parts and is not suitable for large parts due to press size. It is limited to thermoplastic materials only. Matched die molding is a widely used manufacturing process in various industries, particularly in the production of complex, high-precision parts. Some common applications of matched die molding are depicted on screen. Industries benefiting from this technique include automotive, aerospace, medical, sports and packaging. Component made with matched die forming is pictorially shown on the screen. Matched die forming is compared with RTM, hand layup and autoclave molding processes is shown in the slide. It is evident that matched die processing can deliver excellent surface finish products at a rapid production rate. Advancement in matched die forming for composites include automated thermoplastic prepreg manufacturing, upgraded simulation and modeling software.